Hello community! We have a new update on FLAN-T5. And this time we have a look at the XXL version. And yes, of course, we're gonna run it on an NVIDIA A100. But you know, the main question is, and a lot of my viewers ask me, hey, what if I have a model that is too big to be deployed on this classical free Google Colab notebook where we have normally NVIDIA T4 with about 16 GB of GPU memory. And I can tell you, if we go now here, for example, to the Google FLAN-T5-XXL model, we need about GPU with about 80 GB of memory. And we will use some mixed precision or some sharding to fit the whole model on a single GPU. Here in my Hugging Face, and I put in FLAN-T5-XXL. And here we have our Google FLAN-T5-XXL. Now you can spin up here, no problem. But I was just going down. Here you have, the languages. Those are the languages it has been trained on. And of course here you have the FLAN-T5 checkpoints and the original FLAN-T5 checkpoints. Yes, if you want to read about FP16 and Int8 and everything is here, but what I wanted to show you is this here. Maybe increase it a little bit. And here are the different models. So last time I showed you here our parameters, 3 billion parameter model, the T5XL. And now we go with the 11 billion parameter model, the T5XXL. When the FLAN, in particular the FLAN-T5-XXL. And you have here the different benchmarks. You have here 57 tasks, 23 tasks. So here a compendium of different benchmarks, and you see how the models compare the FLAN-T5 and of course POM. And you see here going from 3 billion parameters to 11 billion parameters. You do have some increase here in the performance. But the real mover, if you look here, then here at the 540 billion parameter model like POM, or then some derivation where you can see you really go up here in the performance indices. So just to give you an order of magnitude where we're operating, so we are here on a T5XXL model before we will switch to POM. FLAN-T5XXL. I noticed there is a new one, Phil Schmid. So I had a look at this. Fork. You can deploy the FLAN-T5-XXX with one click. We are using a quantized version. Okay. Create a new endpoint. And if you want, I have no idea what an Huggingface endpoint is. If you want, we find out together how we can run this model here on Huggingface endpoints. So I get interested here in this picture. You have a model repository from Huggingface, from the Huggingface hub. That's beautiful. Then you choose more or less a cloud provider, AWS, AZURE, or Google Cloud. And you have your regional hub, and then you choose, okay, and I said, okay, I'll have a look at this. Yeah, again, languages, everything, checkpoints, everything for you. But I said, okay, let's start here. So I said one click, so let's have a look together. Huggingface, Inference Endpoints. Welcome to Inference Endpoints. You can easily deploy your models on dedicated, fully managed infrastructure. Keep your costs low with secure, compliant, and flexible production. Add your credit card. Yippee! Add my credit card. This is what I want to hear. So we have a look at the documentation. And maybe get an idea what we are talking about. So, endpoints. 2 pricing plans, but what are endpoints? Let's go here. Secure production solution for easily deploy any transformer, any sentence transformer, any diffusion model from the hub, from the Huggingface hub on auto-scaling infrastructure managed by Huggingface. Now this is nice. You know what this means? This means that whatever we have, where am I? Whatever we have here on sentence transformers, for example, whatever model we have here in the Huggingface, we can use this repository here and run it on some dedicated infrastructure. Now, this is nice. This is very nice. Okay, support all transformers, sentence transformers, and diffusion tasks. Now, this is really, really nice. Okay. So, stable diffusion. 1.5, updated 4 days ago. Okay, yeah, by the way, I wanted to show you FLAN-T5 large model has been updated, and the FLAN-T5-X large model has been updated 7 days ago. So you see here FLAN-T5 from Google, FLAN-T5 large, 270,000 downloads, updated 1 day ago. Yeah, but what I wanted to show you here, that it is actually brand new, what I want to show you, if I'm gonna find it. Phil Schmid spaces. Here we go. Phil Schmid FLAN-T5-XXL shorted FP16 floating point 16 updated 1 day ago. This is what we're gonna have a look on. Just 8 downloads. Here we go. Yes. So it's rather brand new, and we're gonna explore now the endpoints. Gee, I'm a little bit confusing, but never mind. So what we can do, we have AWS, we have AZURE, and we have Google Cloud. Beautiful. So we have a user. Beautiful. Then we create an endpoint. We have here the Huggingface repository with our sentence transformers or our vision transformers or our, I don't know, diffusion. We build a container. We initialize the compute infrastructure. We deploy our endpoint either on AWS, AZURE, or on Google. And we have an up and running endpoint, which would be great in the cloud. Now, this sounds interesting. Compliance, yes, everything's encrypted. Supported task, what can we do? Oh yeah, that's nice. Have a look at this. Text to image, text classification with transformers, zero-shot classification, out of the box. Question answering, summarization, translation, text to text, generation, feature extraction, ranking, image classification, object detection. Okay. So, nice, everything more or less up and running. Pricing, let's look at the pricing. So what do we have? We have CPU instances, okay? So we have here AWS, and here we have AZURE. And you see here with 16 gigabyte of RAM, we have hourly rate half a US dollar hourly rate. And AZURE, $half hourly rate. Beautiful. GPU. So which GPUs do we have in the cloud? We have only AWS. This is interesting. Yeah, and here we have our typical T4 with 14 gigs. And this hourly rate of $0. And then, this is nice, 44. Okay, but we need minimum 80. So we will go with an AWS X large, NVIDIA A100, 80 gigabyte memory, and it will cost us what they say hourly rate $6.50. Pricing example. How is it calculated? Replica. Okay. So you have here, you can calculate monthly costs, hourly costs, monthly costs. Okay, if you want to run it for a company, okay. Advanced endpoints, auto-scaling. Okay, if you need auto-scaling from 1 to 3 machines. Beautiful. What else? Let's have a look at this. Yes. Okay, create your first endpoint. Here we go. Enter the Huggingface repository idea and your desired endpoint. So if you insert your personal credit card, not mine, but take your credit card, thank you. You will end up, I suppose, where was I? Here. And so you have an endpoint. And then you define the model repository. Now, our model repository is, of course, here. Copy. Phil Schmid, FLAN-T5-XXL shot at FP16. This is it. We will, where am I? Input this here. And you can give the endpoint a name. Most beautiful T5-XXL endpoint ever. Beautiful. What else? Let's make it a little bit bigger. We select a cloud provider in a region. Only AWS will be available as a cloud provider for East and EU West 1 region. So we have AWS more or less. North Virginia, Ireland, Frankfurt, Oregon, Hong Kong. Beautiful. Define your security level, public, private, protected. Create your endpoint. By default, your endpoint is created with a medium CPU. Cost estimate, assume the endpoint will be up for an entire month. The cost assumes the endpoint will be up for an entire month and does not take auto-scaling into account. Wow. Does this mean we have to pay for an entire month, or this is just an option and I can go with some hourly rates if I just want to have a job for 10 or 12 hours? Okay, so create endpoint tells me what it costs per month. Wow, if I have $6 per hour for my GPU alone. So you wait for the endpoint to build, like we know from AWS and whatever, 1 to 5 minutes. Yes, okay, yes. And we test your endpoint in the overview with the Inference widget. And we have to get an address. Where's our address? Ah, here. Send requests to endpoint. So now to be able to send something to this endpoint that is up and running in our cloud, we need some address. Here, copy as URL. Beautiful request. Should this assist? Yes. Ah, here we have input and your authorization. Beautiful. Inference API, the SageMaker, Inference Toolkit. Okay, update your endpoint. Update your endpoint? Why would you? Okay, again. Okay, if I see I want to upgrade my machine, I have here CPU, small, medium, large. Beautiful. Auto-scaling. You can update the auto-scaling configuration. Okay. Advanced setup. Ah, here we go. Okay. AWS instance, CPU medium, and a small GPU. And we would go with a A100, a GPU X large. Task, framework, revision, image, yes. Create a private endpoint, create custom inference handler. Yes. Okay, I see what I mean. Okay. Here, I would like to switch to another presentation I found by Phil Schmid. I just added it in the internet and I found a very nice article here on what it is, www.philschmid.de, deploy /-T5 -11 billion. Look, there's a beautiful thing. There even is a code. Deploy 11 billion parameter model for inference for less than $500. Let's have a look at this, because at first, open link, and we have here, oh, this is more or less, no, this is T5 sharded. Ah, yeah, here we have it. There you have the code, yes. But the article, this is a very nice presentation. Have a look here. This is tutorial cover how to prepare the model repository, custom handler, additional dependencies, deploy the custom handler as an inference endpoint, and send your HTTP request using Python. This is what I want to show you. So he explains here what is our Huggingface Inference endpoint. Beautiful. You know this already. On a single NVIDIA. Yeah, this will not work. Normally too big to deploy on an NVIDIA T4. To be able to fit T5 11 billion model into a single GPU, where goes, yeah, exactly here. Look, makes precision and sharding. You notice I showed you. And here he introduces, I haven't showed you this, LLM.integer8, a new quantization technique for integer 8 matrix multiplication, which cuts the memory needed for inference by half. Which, wow, okay, great. Yes, has a repository, yes. Here, and if you want to convert the weights yourself to deploy FLAN-T5-XXL, you need at least 80 GB of memory. Yes, we know. look at this. This is not so complicated. Torch, transformer, Huggingface hub, beautiful. Load as float 16. You know this. This is our model, as I showed you 100 times before. Model with language masked head from pre-trained. We have here the T5 11 billion model, torch type, float 16, like I showed you in my last video when we implemented the XL version on the free Colab notebook. Low CPU memory usage true. Okay, interesting. Shard model and push to hub. Beautiful. After we have our sharded FP16 model, yes, but we have this already. We are gonna use his. Yeah. You agree? I agree. We both agree. Beautiful. So after we have our sharded weights, we can prepare an additional. We need element. Yes, as natively. Yeah, bits and bytes. You know this. I showed you this. We need to accelerate. We need the bits and bytes. Documentation and the endpoint handler. Beautiful. Look, this is all I think that we have already. I showed you before. We have the pre-process. We have our tokenizer. This is so simple with our input IDs. Then we have model generate. This is our output function with some parameters else, without some additional parameters. And then we have the post-process stage where we say, okay, decode, yes. And then we have return the generated text and skip special token, exactly like I showed you in my other XL video. Beautiful. And then we deploy the custom handler as an inference point. So here we go. Yes, we're gonna use his model repository. And his model repository is... No, it is not this one, but it is... Oh, come on. FLAN-T5-XXL. Here, this one. We're gonna use this one. Phil Schmid, FLAN-T5-XXL sharded FP16. This is what we're gonna use. This was updated yesterday. So, where was I? A little bit confused, but we managed it. Don't you worry. So, this is our model repository. We can use an endpoint name, whatever you prefer. Okay. Open advanced settings, select GPU small. We go with GPU X large because we changed the repository. If you're trying to deploy the model on CPU alone, the creation will fail. Yeah, well, okay. Have an idea why. The Inference Endpoints service will check during the creation of your endpoint if there's a handler PI available. We use it for serving requests no matter which task you select. The deployment will take 20 to 40 minutes. Okay. This is for the small model, so expect an hour to 3 hours. We can test it using the Inference widget. Test your endpoint. And here is exactly, you have here text-to-text generation task. Is a compute, and this is the answer generated by the system. Beautiful. So what do we need to do? We have now something up and running in the cloud, and now we just have to send an HTTP request, and we do this in Python, the easiest thing. You know our old friend, PPP install requests? My goodness, this is when I was back in school. Yes. Import JSON, import requests, our endpoint URL, inputs, translate English to German. Okay, if you want this task, you can define the maximum length. Beautiful. You have here the authorization, and then you simply send your request. And here we go, r.post endpoint URL headers JSON payload. Response, the generated text. Show me the generated text. How easy is this? So more or less exactly what is running here on our Google FLAN-T5-XXL, the hosted Inference API. You put in the text, click compute, and you get the response. Timed out. Maybe we should start it. Model is loading. So either if you have a concrete task, I would recommend have a look here at the full Google FLAN-T5-XXL. See what comes out. Model can be loaded on Inference on demand. Oh gee, that's gonna take some time. I'm recording this at the evening, so heavy internet traffic, of course. So where were we? And that's it. Conclusion. This is it, how you deploy Phil Schmid FLAN-T5-XXL model here on, what's it called? Huggingface? No, the other one. Huggingface, my goodness, Inference Point. Where is it? Here. Huggingface Inference Endpoints, a fully managed infrastructure. I think currently with AWS and a little bit of Azure, currently without any Google integration, but I hope they will also integrate Google. So there you have it. Now, successfully deployed the 11 billion parameter T5 model Huggingface Inference Endpoint for less than $500. Less than $500. Okay, he uses, as we saw, a T4. GPU small NVIDIA Tesla T4 with an auto scaling up to 2. So he says, I suppose these are the monthly rates. Underline, we deployed one of the biggest available. Yes, 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 yes. Sign up and create something beautiful. Interesting, interesting. So something completely new. I discovered this together with you. I just had a glance over before I started this video, but I thought, hey, why not have a look at this? So if we assume that we take here a T4 that costs $0.6 per hour, I would say this is the monthly cost to deploy the T5 11 billion parameter model on a T4. We have here our Google FLAN-T5-XXL. Now you know how, timed out again. You know how to run it on an A100 with Huggingface Inference Endpoints. We saw that we have this FLAN-T5-XXL shot at FP16 is great. And he tells us that we can go away here if we use a GPU medium, an NVIDIA A10G. And we know pricing, NVIDIA 10G with 24 gigabytes. Wow, this is NVIDIA 4090, I think, has also 24 gigabytes, if I'm not right. I don't know. So we have an hourly rate of 130. Thank you for exploring this together with me. It was a little bit confusing, I know, but I try to have fun whenever I learn something new. Machine learning at your service. It's so nice that you have all transformer models, all diffuser model, all sentence transformer model. So if you really have a huge task, you can go. You do not have to go to AWS or AZURE or Google Cloud, but there is a nice Huggingface interface for you. Nice. I don't know if it's really competitive. If some viewer have some overview and they used both and they have also experienced here with Huggingface Inference Endpoint, please leave your suggestion, your experience with this cloud model for us to learn based on this. I say thank you for watching. It was a very spontaneous video recording. I hope you enjoyed it the same way I did, and I'll see you in my next video.